Hey everybody, this is Becca from Empowering Pumps and Equipment. We are the online resource for the pump and related equipment industry. Today I have Peter Woodman from Everactive. And Peter, why don't you introduce yourself?
Hi, Becca. I am the principal sales engineer here at Everactive. So I help our customers figure out if our sensors are a good fit for their environment and answer any questions they might have about our technology.
Awesome. Well, great to have you here, Peter, and I'm excited to learn with you.
Yeah, I think it's going to be fun to get people in front of this technology. So, first, I just wanted to say to the folks here on the webinar, thanks for joining us. Many of you might have been thinking about digital transformation for a very long time. Others, this might be new to them, but in the current state we're in with COVID, I think it's given people a lot of chance to kind of reevaluate, what happens when you're on site versus off site, what it means to be able to get access to your data from anywhere. So that's been a driver for us. And I thank you for joining me this way, kind of over the wire. So wanted to first talk about kind of what it is we're going through today, and that's our machine health monitoring solution. That's for monitoring things like pumps, fans, any rotating equipment. So this little green cube here, it's the first of its kind. It's a screening tool for vibration analysts that's always on, continuously taking triaxial accelerometer data and sending it up to the cloud. I think in the right hands that it could change your career. So we'll talk a little bit more about that in our later slides. But for now, just know that this sits out on the edge and feeds back new data streams from all your machines, giving you continuous insight into how your plant's operating, including alarming. A few things I wanted to highlight here. We have great range around industrial environments, continuously on and operating, so it doesn't have to shut itself off like a battery-powered sensor. And we think of it as truly being self-powered, so you don't have to go back and swap out a battery or maintain it in that way. So that's what interests most people in us, is that we're batteryless. So I want to talk a little bit about that. There are 4 sources shown here that we can harvest energy from. We're working on a 5th as well. The focus for our machine health monitor is these 2 on the left. So temperature differential, something that's warmer than the ambient air temperature or colder. In this case, a warm spot on a machine or a pump or the equipment around it, or the presence of light. And that could be indoor light like the LEDs or CFLs or incandescent bulbs you're sitting under now, or it could be outdoor light like the sun. Now, this is not a lot of electricity that you get from harvesting from these sources. It's a very small amount of electricity. But at our core, our technology is the lowest power electronics and radios in the world. And that's what allows us to use these very humble sources of energy and still power our sensors continuously. The conventional electronics you're probably used to seeing around your plant require a lot of electricity from the very base of their design. So we started over. And our co-founders are researchers at universities, the University of Michigan and the University of Virginia. And they started by creating these very low power radios and low power processors. When you bring those together, you can get away with some pretty humble sources of energy and still run continuously. So let's talk a little bit more about how this fits in to sensing things and the industrial Internet of Things. The Internet of Things in general has not lived up to its hype. Back in 2012, the IBM Watson team said that just 3 years later, in 2015, there would be 1 trillion IoT connected devices in the world. That's a huge number. And 2015 came and went, and we were nowhere near that. Everybody who's taken a swing at projecting since then comes up with a much smaller number. So this is 50 billion, not 500 billion, not half, but 50 billion. And then it's shrunk again. Analysts say today that we're somewhere in the high teens, maybe around 20 billion IoT connected devices. And that's everything from smartphones and wearables to your smart toaster or refrigerator, still to be under 20 billion. The industrial IoT is a small fraction of the number of IoT devices that are out there in the world. So there are very few industrial IoT connected devices out there, fewer than we ever expected at this point. And it's not because people don't want that data. They do want continuous insight into their equipment and how it operates. But there are 2 factors that have kind of artificially lowered the ceiling. The first here being batteries. So batteries, from a logistical standpoint, we've met a lot of folks working around these plants, women with titles like reliability engineer, maintenance planner, that sort of thing. But I have never met a woman with the title battery changer. So when you ask somebody to change a battery, you're stealing cycles from something else they could be doing that's more important or is more difficult to train on or more intricate. So that's the first piece. But it's not just the person who changes the battery. The maintenance planner has to schedule those repairs, make sure you have the right batteries in stock, and do that all before the batteries expire or you lose data. They also have to do something with the batteries that come out of these sensors once they've expired. And that's the environmental piece here. So when you think about batteries inside industrial environments, they package them up really heavily to make them intrinsically safe. And they usually make them out of heavy metals to begin with. Both of those things make them very difficult to recycle. As a result, many industrial sensor batteries end up in a landfill. We've even seen entire sensors that aren't made to have the batteries replaced. The battery is soldered into the sensor, and the sensor itself is designed to be disposable. So they go straight into a landfill, which is really unfortunate. The environmental impacts of that will never scale to hit 1 trillion IoT connected devices. Even if we had this kind of fantasy battery life of 10 years, most industrial sensors get around a 2-year battery life on average. But let's say we could stretch that out 5 times to what it is today and hit a 10-year battery life. As those sensors aged out, there'd still be 274 million battery replacements every day. So you'd need a lot of those fictional battery changers running around plants. But there are other trade-offs too. So we talked about the battery piece and what that does in terms of a human cost, but there are trade-offs in the sensors themselves. As a result, since they're difficult to deploy and maintain, there aren't as many of them out in the world as there should be. People choose not to sensor up all of their assets. They'll put a sensor on the top 5 or 10% of their assets, but be missing out on data from everywhere else. The sensors themselves ration out the amount of data they send, and they do that in order to milk that battery life as long as possible. So you get reports a couple times an hour to a couple times a day instead of continuous insight. And that leaves you having to get by with the minimum amount of data instead of the maximum. So you can't always make a good decision with the amount of data you're getting. So since our sensors power themselves, it's a different model. They're continuously on, always providing data, not rationing out how often they send. They do this using those low levels of harvested energy that's usually plentiful right nearby whatever it is we're sensing. And they're made to be ruggedized as well. So that IP66 rating is for water and dust intrusion into the sensors. They can be outdoors in all 4 seasons. You can hit them with a fire hose, and they're dust and sand proof. That class 1 division 2 refers to intrinsic safety. So they can be in hazardous locations up to that rating. And we support a wide temperature operating range. We've been outdoors here in the upper Midwest when the polar vortex hit a few winters ago, and it was 40 below, all the way to steam tunnels in the south in the summer where it can be 180 degrees Fahrenheit without ever missing a measurement. As that data makes its way up to the cloud, we think of it as a new data stream. Because if you're used to getting like quarterly reports back from your vibration analysts as to how your motors are behaving, in the first hour that our sensors are on, you'll get 15 years worth of that data. Now that's way more than you could keep up with by reading through it like you do with an external report today. So we have notifications in our platform where we can call your attention to the assets that are in most need of attention, and then you can schedule your repairs. Should make you much more efficient. Most of those notifications today are sent over email, but we do have an API as well. So if you have another business system like a work order system or some other data lake where you want to warehouse this data, we can hand it off to you also. Everything on this slide comes from us, one company. We're not bringing together disparate solutions from different companies. So you'll never get stuck between 2 different companies saying, hey, that hardware is their responsibility or the software is the other guy. It all comes from one single support organization. So if you have a feature request or a support issue, we can solve it really easily. Once again, without ever having to change a battery. So by the time that science fiction technology we saw on the previous slide, these harvesters makes it to you, we've thought through everything you need in order to instrument your equipment. The sensors themselves and how they mount to the equipment is thought through. The gateways that take that sensor data and aggregate it and send it up to the cloud are included as well. Each one has a cellular modem in it with a SIM card that's already active for 4G LTE. So you don't have to worry about connecting to get your data flowing. Within a few minutes of opening the box, data begins flowing to the cloud. We can provide installation of these sensors as a turnkey service, or we can instruct you on how to do it yourself. Once that data hits the cloud, you can access it from any modern web browser. So that could be a phone or a tablet or a PC. You just log in with a username and password and you're ready to go. You don't need any server or specialized app locally. All right, so let's take a look at the actual sensor itself. Here's 4 of them instrumented across a machine train. So anywhere you see one of these little green cubes with a fin on the top, that's our sensor. Each placement location, you're getting triaxial accelerometer data. So there's actually 12 points of data coming across this machine train. A little bit about our harvesters here. This little puck here with the blue fins on it is our thermoelectric generator. So it's connected via a cable. We can make those in a bunch of different lengths to connect to the sensor. That's modular, so you can disconnect and reconnect those cables to suit. We place this out here, find a warm spot nearby, set our thermoelectric generator down. And then if there's times where the motor is warm and times where it's not, we can also use a solar harvester to bolster it. So you'll see here, this one sensor has 2 sources of harvesting nearby. Now on this particular example, this is a boiler feed pump. So the motor itself runs warm at some times and other times it's close to ambient, which is why we're using 2 harvesters. The driven equipment, the actual pump, that's a hot water pump. So we know anytime it's running, it's going to be hot. So we use this thermoelectric generator to scavenge that waste heat that emanates from it. And that's all we need to power the sensor in that application. Taking a little look through the parts of the solution itself, the sensor, this is the brains of the outfit. So that's where those super low power radios I talked about are and the processor is. We don't use batteries anywhere in our solution. Even rechargeable batteries have a limited number of cycles until they wear out and you have to go back and service them. But we can store energy on board on this sensor by using supercapacitors. They don't store as much energy as a battery would, but we don't need very much. And they're rated to last over 20 years. So you can set this sensor out and know that you won't have to go back to do a battery change, in 18 months or 24 months. A couple different options for mounting this. I'll show you those here on the camera in a moment together. This is a smart sensor. So in addition to getting the overall vibration levels from our accelerometer, we can also generate an FFT, a fast Fourier transform right here at the edge and send that back as well. So you can use that to analyze the frequency magnitude pairs in the vibration spectrum. As I said before, we're indoor or outdoor all 4 seasons, so we can support spray down and whatever else you might throw at us to an IP66 rating. And it doesn't require a very hot motor in order to power this sensor. If it's warm to the touch, about 15 degrees Fahrenheit difference from the air temperature, that's all we need to get by. Under the hood, as I said before, primarily people are looking at the triaxial accelerometer for the vibration analysis data, but we also have a magnetic field sensor, and that can take the rate of stator excitation that the VFD is feeding to the motor and report that as well. So we report that in Hertz. You can take that, put it alongside your accelerometer data, figure out what 1 time is and see if there's slip between the VFD and the motor. We also have temperature data at the sensor and also at the skin temp of the motor. And humidity readings as well in the room. This is a smart sensor. It's capable of receiving software updates, firmware updates, and executing code that we send to it over the air. So you'll never have to go back to do a software update or a firmware update. You place this once and we can manage it remotely for its entire life. Close up here on our thermoelectric generator. This is also magnetic, but could be epoxied down if you don't have a magnetic motor. It's the warm spot on the motor, the difference between that and the air that generates our power. So these fins here are what allow us to exaggerate that natural temperature differential and generate the most electricity possible in a small spot. This doesn't necessarily have to be right on the motor body. If there is driven equipment nearby that's warm or something else nearby that generates heat, you can place it there too. Wherever we place this thermoelectric generator, it'll report its temperature. So we can use that as a trending data point as well. And our solar harvester, this is the energy source that harvests light. And when we say solar, that means the sun, which can be confusing because it also works for indoor light. So they also call this a PV harvester sometimes for photovoltaic. But you can place this anywhere as well nearby. The cables we make run 10 feet or longer if we need to. So we can use a short one if it's a short throw, so you don't have a lot of slack hanging around. But if we need to get further away to find daylight, we can run a cord too. So I'm going to end the slideshow here for a moment and switch over to my camera in the room. So I'll stop sharing here and move over. So I have a small motor here in the room with me. It's a 7.5 horsepower Marathon, a little pulley on it. Just to give you a sense of scale, I've put a can of Coke here so you know what size we're talking about. And I'm going to walk you through installing our sensor and what the individual bits and pieces are. So here's the sensor itself right there next to the can of Coke and here up close. So you can see this port on front. That's where we plug in our harvesters. So that's a USB-C pin out, like you might see on some cell phones or laptops. But what makes ours a little different is, in order to make it waterproof, we add a gasket to it. So there's a rubber gasket material and that safety screw to make sure it doesn't get yanked out, kind of unceremoniously. So that's the connector port. This little shield on the front here, this black button, is made out of Gore-Tex. That allows us to get temperature and humidity readings without compromising our waterproofness. So that's there on the front. We have a little wake up light on the top that gives you a heartbeat when the sensor's on, so you know that it's running. I'm going to take our base off here and show you the options for mounting this. So we have a screw there to keep it set. And then this mount comes off. So if you had to epoxy this down to the motor, you could do that and leave it behind and swap the sensor out if you're doing service on it. It's also magnetic. So most of our customers just set it on their motor, and it's strong enough to keep the sensor on in any orientation, whether you're vertical or horizontal mounted. We can also do a stud mount. So if you've got a tap and die into your motor, to mount another sensor or accelerometer already, we can just screw into that, and that'll keep it steady as well. So get that connected. All right, so I'm going to set that there top dead center. And now I'm going to grab our harvester. So this is the thermoelectric generator I talked about. You can see those fins. On the bottom, we just place this on a warm spot along the motor. It's magnetic, but we also have some little stabilizing feet we can fold out to keep it still. So this is our power source. You can see it's pretty small. It's about 2 inches square plus the connector cable. And it doesn't generate very much electricity, but we don't need a lot. I want to give you a point of reference. I'm wearing an Apple Watch here. This is considered the most power efficient consumer electronics in the world. It has a very small battery and it lasts all day. The 4 big consumers of electricity on this watch are LTE, Wi-Fi, the screen, and Bluetooth Low Energy. So 3 of the top 4 are radios, which is kind of telling, right? The lowest of those 4, Bluetooth Low Energy, has a power budget of 50 microwatts. And the way it achieves that number is it powers itself off 99% of the time and fires up in little blips to talk to my phone or my laptop. The radio we have in here, our Evernet radio that's always on and always listening, has a power budget of 200 nanowatts, 1,000 times lower than BLE, which is the number 4 consumer here. So to charge this watch, you would need a thermoelectric generator like the size of this table on a very hot spot, which you're not going to find in most industrial environments. There's a lot of places you can find a little 1-inch square in the center of this that's warm. So that's our advantage there. We can use very small harvesters and still get by. So I'm going to connect this up here. Thread that in. Now, if this motor is hot sometimes and cool other times, I talked about our capacitor banks, but we also can bolster with a solar cell. So here's the solar harvester we use, or PV harvester. It's about the size of a playing card, maybe half the thickness of a deck of playing cards. And then there's holes in the corners we can use to zip tie or screw it in, but it's also magnetic. So it's got the same pin out as our USB-C pin out we use elsewhere. And you can actually daisy chain another cable to this to have both of them together at once. So I'll set that there. So that's the physical aspects of the solution, kind of what it looks like to install one. They go on really quickly. We've put dozens of these out in a day with one person, hundreds if we have teams, and they can be pretty small teams. And within just a few minutes, in the amount of time I've been on this camera view, if we had that thermoelectric generator hooked up on a warm motor, we'd already be streaming data to the cloud. So I'm going to put our sharing back on here and show you what happens to that data once it leaves the sensor. It goes through our pretty standard looking IoT gateway and then hits the cloud where we can visualize it. So you can see here in this view, I've got every individual measurement. So each of these color bars is a chart with the overall vibration level and IPS peak of that triaxial accelerometer. So here's an example of a motor with some peaks on it that's running rough. And you can see we can hover over each individual one down to the minute to see what's happening. If you were spot checking this motor, you'd have to be there at pretty specific times with your accelerometer to figure out what's going on here when. Likewise, if you had a battery powered sensor that only phones in a couple times an hour, you wouldn't have nearly as complete a picture of when this is peaking out and how rough it's running. We use thresholds for vibration level on these machines. So I'm actually going to turn off 2 of these axes, and the one that remains, that pink bar, is when we're in alarm. So you can see exactly how long the machine's running rough for. We can also click and drag on any one of these areas to zoom in. So now we can get down to our individual measurements. And you can see these are up to the minute. So 53, 54, 55. Charted alongside those vibration levels, we have our temperature measurements as well. So the ambient one comes from the sensor body, that's that 118, and then the surface comes from the thermoelectric generator. So wherever we've placed the tag, we can chart that as well. And you can see during those spikes when that motor's kicking on, it does get quite a bit warmer. So this is one visualization for the data. Another one we use is those frequency magnitude pairs, some actual spectral analysis. So if we got this alarm, we know we're peaking out here, something to look at. I'll go into our FFT view and we can click to highlight just that peak. And then we'll see down here the frequency magnitude pairs for each of those sensors, or axes, I should say, at that time. So we know that our most severe was around the tangential. I'll scroll down there. We can see here, that's where our biggest spike is. I can also click and drag to zoom in here and see if there's something worth looking at. A little bit of low level vibration there, but the big spike is here right around 3,200. So your vibration analyst from there can say, hey, it looks like given where we're seeing these peaks, the frequency and both the magnitude, let's go check on this. And given context around the equipment, you can determine exactly what repair needs to be done. We store a lot of metadata here in the cloud, so it can give you more insight into what it is you're in for when you head up to take a look at that pump. In the case of this one, we're just storing a little bit of basic metadata, but we actually have tons of additional fields we can store, like horsepower, the motor manufacturer, things like bearing part numbers, line frequency, all that stuff. So a pretty rich platform. We can also set our vibration levels here as well. So. All right, so that's a quick look at our software, but most of our customers are responding to alerts, right? They're not driving through that platform looking for faults. They're waiting to be told something's wrong. So by placing these out on the edge and setting intelligent thresholds, you'll be alerted when there's a problem, and then you can focus on that. So a couple notes about what it is our customers love about us. They've told us that we made their installation really quick and easy. And that's true. We work together with you. We're not just selling sensors. We work together with you to make this service work. So you don't need specialized tools or prior IoT knowledge to get up and running. We provide everything you need. We could do the installation for you or work together to make sure it goes smoothly. And as I said before, that happens usually within a few minutes of opening up the box. Other things our customers love, we don't have to bother their IT staff. Like 95% of our installations today are using pure LTE from the gateway layer up. So we don't have to spend a lot of time requesting Ethernet drops or asking IT for assistance in troubleshooting. We're a self-standing solution. We sell this as a service, and that de-risks it for you. So instead of making a huge upfront investment in the hardware and then trying to make sense of it and see if you get a return, we are incentivized to stay with you on that journey. You don't have to pay a huge upfront cost and try to write it down as the equipment ages. You'll never be stuck with hardware you can't use. We'll be with you there covering it to make sure it works. So it's an all-in model. If a gateway goes down, we have a team that monitors those on the back end to make sure. There's a sensor issue. Let's say you have a premature hardware failure, we'll ship you a new sensor. So for you, this means it's something that works completely right out of the box. You're not adding this new maintenance task of replacing batteries in order to go out and get that data. And you get access to 24/7 continuous monitoring and alarming on all your equipment, which makes it a lot easier for you to understand what's going on in context. Now I want to talk a little bit about what we aren't, what we are not. There are some of our competitors that say, hey, AI and machine learning, predictive analytics, we're telling you, you can replace your vibration analyst with just a sensor. We don't think that's true. It's our job to empower vibration techs, right? So we want to give you all the information you need to make an intelligent decision. Our competitors who say that a sensor alone, somebody sitting on the other side of the world looking at sensor data can tell you precisely what's wrong, we think they're bluffing. But for our existing customers, they've seen us as a force multiplier, so they can screen from anywhere. This quote I liked: since COVID hit, we've had fewer personnel on site. It was hard to keep up with the monthly routes. Now this person monitors remotely, and when they see a problem, they can respond as they need to. So it's a force multiplier in that way. We also think it'll help your efficiency. When you are on site, you'll know exactly where to go and what to do. So this quote, my employer's money and my time is much more well spent screening than running around and trying to find problems with manual measurements. And from what we've seen talking to vibration analysts, if you're running a route, like a monthly route, probably 80 to 90% of the measurements you take are going to come back as being within spec, expected behavior. In our opinion, those are wasted trips. If you're going to go out and measure something that's good, why bother, right? By putting sensors out there at the edge, they'll tell you when something's bad, and you can focus your attention on only what's bad. Since we're continuously reporting, you're never going to miss a measurement on equipment that is running intermittently. So we had an example, somebody told us where they needed to get vibration data off of a pump that tended to run overnight on the night shift. They called an operator in to turn it on and run it. But even then, they were running it synthetically. It wasn't genuine data in process. So from this quote here, they don't have to call in an operator to power up a specific piece of equipment. We can capture machine data in its normal running state as it's happening. And I think that's an important distinction, being able to see what it actually looks like under process, not some synthetic run that you did just to gather data. As you saw, we keep all of our data online. So you can recall any one of those measurements in the entire history in the time our sensor has been on. Even if the sensor is swapped out, because it's damaged or there's a problem, we keep that data online in the dashboard so we can substitute a new sensor and you'll still have continuous access to the previous records. So in this quote, I can look back at trend data over months or even years to see how the machine has performed under comparable loads over time. I think that's important. We want you to be able to go back a year and see how that machine was behaving under a similar load back then. Some of our competitors will nickel and dime you for data access. We don't believe in that because I don't think you can make an intelligent decision if you can't see all that data. So this can feed all kinds of things around your environment, right? That could be that we use the API to feed another business system and file a work order automatically. Could mean that you're warehousing it in a data lake. You could feed it into part of your OEE data to understand your process, from a complete picture, holistically. So once this data is flowing, you get complete access to it in the cloud from anywhere. So whether you're standing right next to the motor, or working from your kitchen, or getting away from the plant entirely, you can still check in on your assets from anywhere. We think it'll really change the way that people approach these types of tasks. So I talked a little bit about our service model before, and I want to clarify here that we charge a subscription rate per sensor, essentially. So instead of paying thousands of dollars up front for the equipment, we provide the hardware, and you pay a fee to get that continuous data access. In that way, it's de-risked, right? If you take on our monitoring for some amount of time and it's not providing value, you simply discontinue the service, and it's on us to take our ball and go home. So it's kind of a new way of doing business, a little bit different from how people have traditionally approached these problems, but it makes it a lot easier to get started if you don't have to make a huge investment up front. Many of our customers are doing this out of their maintenance budget because they know it's going to be a recurring expense. So instead of having to go out and get a big capital expenditure budget item funded up front, they can roll this on, try it. If it makes them more efficient, it's really easy to demonstrate. I should note we are not just a machine health monitoring company, though. There are other things that we do in terms of sensing around industrial environments. Our first product was a steam trap monitor. So for steam systems, these can be a very costly point of waste. When steam traps fail open, they stop providing back pressure and allow steam to flow through the system. That can be a very costly problem. Machine Health Monitor is our newest product that was just released end of last year. So if we start looking through the platform here, you can see sources we can harvest from and sensing modalities that we have. The checked boxes are ones that we're shipping today. The unchecked boxes are harvesters and modalities that we've qualified in the lab, but we haven't put fully into products yet. So the steam trap monitor is just thermoelectric powered. We know we have a hot pipe, so we scavenge that waste heat and turn it into electricity. In the case of the machine health monitor, it's both of these, as we saw, thermoelectric generator and a solar cell. In the machine health monitor, you get all 6 of these sensing modalities as well. So as you look down our roadmap here, you can see as we check off these other boxes, where else we're taking our technology. Differential pressure on either side of a filter to determine if it's time to be swapped out. Some of our customers are changing filters today on a time basis, knowing that they're going and throwing out perfectly good filters, but they don't have a better way to check how the filter is performing. So, corrosion, so detecting changes in pipe thickness using ultrasound to detect corrosion. Similar thing for leak detection, using ultrasound or acoustics to check for changes in compressed gas or air flows to detect leaks. And also detecting fouling or plugged heat exchangers. Another thing that's on our roadmap there. So that's kind of the overview. Becca, I know we're gonna do some Q&A discussion, and I'd left my camera there on the motor for a minute, so don't want you asking the motor questions. I'm here for you.
We knew you were there, Peter. But actually, I kind of liked being able to see that. And kudos to you for having the very first webinar where you showed us like an actual live demo. That was awesome.
You can ask the motor any questions you want, but it's pretty quiet. I don't think it's going to tell you a whole lot.
I prefer to ask you questions.
Fair.
But thank you so much. That presentation was awesome. And I do have a couple questions for you.
Sure.
So you had talked about, of course, your wireless sensors are batteryless. So can you kind of explain a little bit more on how the circuits and radios are powered?
Yeah, sure. So we looked at two of our harvesters there. Basically, we need to find some source of energy that's nearby. And on motors or pumps, there's often going to be heat. So we always start with heat energy. So by finding a warm spot, just by feel or with a temperature gun, if it's 15 degrees warmer than the ambient air temperature, that's more than we need. So we always start there because that's most plentiful. If you're in an outdoor application and the sun, is visible, you're not covered over, that's another great source of energy for us. So those are the two most plentiful. If we're indoors, overhead lights like the room you're in now or the room I'm in, that's enough to power our sensor too. So just kind of depending on the application. If you think of a motor that's in a very dark place, then we'll use the thermoelectric generator. If there's one that's outside in the sun, that's a great source.
Well, sounds like there's a lot of different options, which is great. So what does a typical wireless sensor deployment look like?
Sure. So we look at each machine train. In the picture I showed, there were actually 4 sensors down the machine train. So one on either bearing of the motor and one on either bearing of the pump. That's not uncommon for us to have inboard and outboard sensors on both the motor and the driven equipment. Not pictured is our gateway, which is a very standard looking IoT gateway. It's about the size of a shoebox and it has a few antennas sticking out. Those are not batteryless. So we plug those into the wall somewhere. One gateway can support up to 1,000 sensors, and the distance between sensor and gateway is about 250 meters, so right around 800 feet. So we place one of those, per zone in a building or area, and it blankets a large stretch of the area with our network, takes all that sensor data and sends it up from there.
Okay. So kind of touching on what data is provided by your sensors and how it can be used, can customers see more than just overall vibration levels? How are your customers using this service?
Yeah, so obviously the lowest hanging fruit when you're doing vibration analysis is that vibration level. We show the overall vibration levels. We also have those frequency magnitude pairs. So we give you some spectral data to analyze as well, alongside that temperature data. And that can be helpful too. There are customers of ours that track temperature data as closely as they track vibration data. So each sensor hands you triaxial acceleration. It hands you those temperatures I talked about and that magnetic field sensor, which gives you important context around the VFD and what electricity is being fed to the motor.
Okay. And so speaking for vibration levels, I had a question while you were doing your demo with the magnets. So with the magnetic base, I'm assuming that it doesn't matter how much the equipment vibrates, that magnet will still stay put?
Well, it depends. So there are some applications we've seen where it runs so rough that it could shake the magnet. So in those cases, we just epoxy down the bases. And the bases are low cost. We can send extras along with the deployment. So if you epoxy it down to a motor and you end up swapping that motor out, you can take the sensor off, leave the base behind, and slide it into a new one. But you're right, the magnet works in many applications, but not just vibration. There could be too much vibration in certain applications. There also are motors that aren't magnetic. Some of them are aluminum, so a magnet wouldn't work at all. So in those environments, we either screw it down with a stud mount or epoxy it in place.
So does your technology provide early bearing fault detection?
It does not. So the accelerometer today gives you data from 6 hertz to 1 kilohertz in that velocity domain. So early bearing detection requires usually higher resolution data than that. That's something that's on our roadmap in the future. For now, this screening tool is designed to tip you off on lots of other conditions below that stage 1 bearing detection. Into stage 2 and stage 3, you may begin to see those types of faults in our sensors.
Well, it's a good thing to hear it's to come.
yeah, it's on the roadmap. So.
Can sensor data be integrated into existing customer CMMS or EAM systems?
It can. So we have a RESTful API that lives up in the cloud where the data is aggregated. So from there, we can use that API to take the data out to any other kind of parallel system, be it your CMMS, EAS, work order systems, historians, all kinds of stuff. So, and we have a public document on that on our website. So if people are interested in getting started with our API, any measurement we take can be exported into another system down to the minute. But we also can provide just things like events, like when there's a failure or a threshold breached. So if you don't want everything we generate, you can subscribe to just the data you need in order to be alert and aware as to what's going on in your facility.
Boy, I like that they can kind of pick and choose what is important for them and then only monitor that. That's a pretty cool thing to have that capability to be picky and choosy of what you want to actually look at.
Yeah, I mean, the funny thing about continuously gathering all this data is there is some of it that is not necessarily going to be valuable at all times, right? So since we're going out and gathering a measurement every single minute, we want to make sure that you don't end up wading through all those measurements and only using the ones that are valuable to you.
Awesome. Well, Peter, thank you so much for your time. And everybody, I hope you thought this was educational as I did, because it was great. And if you have any questions, definitely reach out to Peter. And yeah, thank you so much for your time.
Yeah, thank you, Becca. This was awesome.